Hi everyone. All right, so here we are on chapter 22 and I am going to talk about redox in this lesson. So redox is an abbreviation for reduction, oxidation equations or reactions, okay? So once again, redox is abbreviation for reduction and oxidation reactions. So in a redox reaction, we are going to have a substance, or an element, I should say, gain electrons, and then another element will lose electrons. So one is gaining electrons, and the other one is losing electrons. And these two things are occurring simultaneously, okay? Now, you have to have both. You have to have one that is gaining and one that is losing. If you only have one without the other, then it is not a redox reaction. Okay, so once again, in order to be a redox reaction, it has to have both. It has to have an element that is gaining electrons, once again, and another one that is losing electrons. So to help you remember that reduction gains electrons and oxidation loses electrons, we have this acronym, or what you want to call like a mnemonic device, called oil rig. Okay, oil rig. So this is what oil rig stands for. Oxidation is losing, reduction is gaining. Okay, oil rig. Oxidation is losing, reduction is gaining. So that will help you remember the difference between what is being reduced and what is being oxidized. Here we have a couple of examples of what a reduction reaction looks like and then what an oxidation reaction looks like. And these are what we call half reactions. So let's take a look at the iron equation first. So this iron here has a +2 charge. So this is also going to be its oxidation state. So this iron is going to be +2. And if you look at this iron over here, notice there's no charge written on it at all. And that's a free element, and it's all by itself. It is uncombined, and then therefore this one will be 0. Now if we take a look at the oxidation states and how they are changing from the left side of the arrow to the right side of the arrow, then we can identify if it is reduction or oxidation. Okay, so this is +2 going to a 0. See how the number is going down, right? It's going down from a +2 to a 0. So this is an example of reduction. Okay, so I'm going to put red for reduction. To show, it's showing that those electrons are actually being gained, okay? And when the electrons are being gained, the electrons are going to be written on the reactant side, okay? In this case, it's actually gaining 2 electrons, all right? It's gaining 2 electrons. So when the iron gains 2 electrons, now I know we're saying gaining, but then the number is going down, once again, because it's gaining negative charges, right? So that's why it's being reduced, okay? And you can also tell here what the oxidation states are going to be because the charges have to equal on both sides. So +2, -2 equals 0, and notice how that matches the 0 over here, all right? So they have to also be balanced according to charge. So once again, the number is going from a +2 to a 0. It is gaining 2 electrons. So if you remember oil rig, reduction is gaining. Okay, so that's why this one is reduction. Then if we take a look at the second equation, the copper equation, so this copper over here is going to be copper with a 0 because it has no charge written on it and it's not combined with anything. So this one is going from a 0 to a +2. So that is a difference of 2 electrons. And notice that the number is increasing, okay? The oxidation state is increasing, so that is oxidation, okay? So I put ox for oxidation. And in this case, remember, oxidation is losing oil. In part of the oil rig, oxidation is losing electrons. So when the electrons are being lost, you will see that the electrons are written on the product side, okay, to indicate that the electrons are being lost. Once again, the charges also have to be balanced on both sides. So 0 here, and see how this equals 0, plus 2, negative 2 equals 0, okay? So that is how we can identify what is being oxidized and what is being reduced. All right, so here I have an equation, and what I want you to do is identify if this is a redox reaction or not, okay? Is this a redox reaction or not? In order to figure that out, the first thing that you have to do is assign oxidation numbers to all of the elements. Once all of the oxidation numbers have been identified, then you can see if the numbers are changing or not. You have to have one going up in oxidation state and one going down in oxidation state. Remember, you have to have one reduction and one oxidation in order to be classified as redox. So let's go ahead and assign our oxidation numbers. So this magnesium is going to be 0 because it does not have a charge written on it and it's not combined with anything. Then we go over here to calcium fluoride. It is an ionic equation or compound, so therefore they will just take on their ionic charges. So calcium is plus 2 because it's in group 2, and fluorine is negative 1. Okay, now we go to the other side. This is also ionic, so then these will take on their ionic charges. Magnesium is plus 2. And the fluoride is negative 1. And then the last element over here, calcium all by itself. So then that one will get a 0. Oops, pen option 0. Okay, now let's take a look and see how these numbers are changing, or if they are changing from the left side of the arrow to the right side. So just take a look at one thing at a time. Magnesium is going from a 0 to a plus 2, right? So if magnesium is going from a 0 to a plus 2, then that means that the magnesium is being oxidized, right? Because you see how the number is increasing from 0 to plus 2? So that is oxidation. Okay, now we take a look at the next thing. Calcium is plus 2, and it goes to a 0. See how the number is going down, plus 2 to 0. So if the number is going down, then that is being reduced, okay? Remember, oil rig, oxidation is losing, reduction is gaining electrons. And that's how they get, and that's why they are those numbers. All right, and then let's just check the last one just to double check. Look at the fluoride is negative 1, but it stays negative 1, so there's no change for the fluoride. So we have identified which elements are being oxidized and which ones are being reduced. Another thing that I want to teach you that you need to identify are these things called oxidizing agents and reducing agents, okay? Now the agents are the opposite, so because it causes the other substance to go through either oxidation or reduction, okay? And another rule is the agents are going to be one of the reactants, so it has to be something on the reactant side here. So it has to be either this compound or this whole compound in terms of the agent. Okay, so for an example, magnesium here is identified as being oxidized, right? So that means that the magnesium, since this is being oxidized, then that is going to be labeled our reducing agent. So I abbreviate it RA for reducing agent. And then look at the calcium. Our calcium is being reduced, so that is going to be our oxidizing agent. Okay, so the agents are the opposite. And calcium is found in this compound here. So that entire compound is going to be the oxidizing agent. Okay, that will be the oxidizing agent. And once again, the reason why the agents are the opposite is because they cause the other thing to go through, once again, either reduction or oxidation. All right, so those are things that you have to be able to identify in a chemical reaction. You have to identify if it is redox or not. So this one is yes, it is redox, because we have one oxidation and one reduction. You have to have one of each, once again, in order to be classified as redox. Also, what type of reaction is this? So way back in first semester, we learned about like synthesis, decomposition, single replacement, double replacement, and stuff. So what type of reaction is this one? All right, this is an example of single replacement, right? Single replacement. And you'll also notice that, basically all of your single replacement reactions will be redox. Okay, now let's take a look at this equation. Is this one redox? So once again, in order to figure out if it is redox, you have to assign the oxidation numbers to everything. This one contains polyatomic ions. If the polyatomic ions stay together, you can group them as one unit equal to their charge. Okay, so this whole entire nitrate here can be grouped together, and we know nitrate is -1. Which means this sodium is going to be +1. So the whole polyatomic ion can be grouped together. Sulfate is -2, which makes this barium +2. Okay, so I'm just grouping all the polyatomic ions together. So sulfate -2, sodium is +1, and then nitrate's -1, which means this barium is +2. Okay, so now let's see if the numbers are changing or not. Sodium is +1, stays +1, no change. Nitrate, -1, stays -1. Barium, +2, stays +2, no change. Sulfate, -2, stays -2. So this one is not redox, okay? So not redox. None of the numbers are changing, okay? Now what type of reaction is this one? So this one is a double replacement. So then you can say that your double replacement reactions are not going to be redox. Okay, that is basically everything that I want to go over for today. You have to identify what is being oxidized, what is being reduced, and then also what the agents are. Okay, agents. Okay. So remember, the agents are the opposite, and they have to be one of the reactants. All right? Okay, so that is everything, and I will see you later. Bye.